Hello everyone, I hope you have a great day today. Welcome to this presentation. I'm Jerome Athias. I'm working for the CERT of a French company called TEHTRIS, and today I will talk about incident response with an XDR platform. So our agenda today will be about discussing a scenario of an attack that we investigated. And I will go into the technical details about this investigation and how you can use an XDR platform for doing this task. And we will see what are the advantages of this approach. Then I will provide feedback about this approach and why we decided to act with our technology. Not included in this presentation is the preparation phase of crisis management, aspects of communication around incident response, and the legal aspects such as GDPR. So first, the scenario, you have to imagine a scenario where an hospital has been attacked by a ransomware. So impact is thousands of machines are locked by the ransomware, and the client, the victim, is not using advanced technology in terms of cybersecurity. So we have to respond quickly and to provide the best tools to perform this activity. So the EDR is not deployed, and so we need an incident response tool. And I will explain why we choose to use our XDR platform. We still have Active Directory available, so it will be helpful for us for doing this incident response. So what is incident response? The first phase is preparation, where you will prepare your tools and documents to properly handle all artifacts that you will collect during an incident response and how you will perform a proper communication. Then we'll come to detection and analysis. What are the facts? What are the observables that we are able to discover on the network, on the different workstations or servers, or even network devices? Then we'll try to contain the attack and trying to eradicate it and perform a recovery phase. Then we'll have a post-incident activity, well, based on everything we collected, the lesson learned, and how to perform a better incident response the next time we face this type of incident. This is coming from NIST special publication 861. So I will add a link at the end of this presentation so you can review it in details. So first, what do we need to perform this incident response activity? What we want to achieve is to block the spread of this ransomware, to provide immediate protection of all the devices, all the endpoints on which we will interact with. We want to perform digital forensics for identifying the TTPs of the attackers, to collect the maximum of artifacts, to be able to provide, to perform threat hunting. We want to eradicate completely this malware and block the adversary. So we'll see what are the intelligent blocking features of our technology. Then we want to recover and protect the network. And then we want to come back to normal production, normal operations. So what is the XDR platform? You have to see it as one centralized console coming with a lot of tools. On top of that, this is used for governance and risk management and also compliance. It's normally operated by a SOC, a Security Operations Center, performing managed security services and detection response. And you can have your CERT or CERT performing the activities. So that's one unified console, as you can see. It uses data science, so a lot of data that will be collected by different tools and that will be centralized. It's coming also with artificial intelligence, so it will perform this intelligence on different logs and data collected by the endpoints. It comes with a cyber threat intelligence platform with tools like Sandbox and a huge list of antivirus systems. So that will help us to analyze potentially malicious binaries or executables. It comes with threat hunting tools, which will be very helpful in our task when we will try to track all the TTPs of the attacker and search for malicious artifacts. When compliance is not useful in this case, it comes with an integrated SOAR platform, so it will help us to program potential automated actions performed when some events will appear on our network. So one of the central tools is the SIEM. So the SIEM will help us to collect the logs from the different endpoints, including workstations and servers, but also network devices such as firewalls, email, web servers, etc. So it will be a tool for analysis of all these events and logs, and we will be able also to set some alerts, automated alerts on specific events. We provide also a DNS firewall, which is useful when doing investigations of all the DNS requests on the network. And the core tool that we will be using during this talk is the EDR, so the detection and recovering platform. We also use an EPP, so basically an antivirus system. And we are also able to protect mobile devices with our MTD technology. It also comes with a set of NEDS or IPS systems. Of course, it's compatible with cloud platforms such as Microsoft or Amazon AWS, and compatible with a large panel of systems, including, again, endpoint servers, mobile devices, etc., etc. So this is a view of our EDR tool. So as you can see in this view, you have on the left the list of the different systems that are provided by the XDR platform, the tools that we just discussed. And so it will help us with one unique console to access all these tools and to analyze all the events that are collected by these tools. This is the view from the EDR platform, alerts and events. And as you can see, we have some detection rules that have triggered on our system. So, as I mentioned just before, we will use the EDR agent. So that's one unique agent that you will have to install on the machines on the network that we want to analyze. It's easy to do so using GPO or tools for network deployment. So that's a rapid response tool. This tool is compatible with Windows, but also Linux systems and Mac. It performs immediate visibility on the console. So as soon as the EDR is installed, it will start collecting events and logs, and it will automatically send these events to the main console. It comes with a centralized configuration that will make it easy for us to change the parameters and to enhance the detection, basically also using artifacts that we'll be collecting in the next slide. We can harden the system and its live system. The first objective is to block lateral movement of the attacker, and block the spreading of the attack. So it comes with an automation of the forensics artifacts collection. So that will be a main difference between the EDR approach, the EDR deployment approach, basically directly using our XDR platform, and other different tools from incident response, where will you only be able to search for artifacts, to perform queries on your network, but that will not react in live. A small con is the modification of the file system. Of course, we will need to install an agent of the system, so it comes with some modifications. So now the forensics part is the main part and the most important during incident response. So with a tool integrated to the EDR agent, we will be able to perform fast and efficient diagnostics. Between these diagnostics, we will perform processes analysis. So we will obtain directly the list of all the processes that are executed on the endpoints where the EDR is installed. So we will be able to review this list and to perform analysis for detecting malicious binaries that are executed on the systems. We will perform an analysis of network connections. So we are trying to identify if the endpoints are connected to malicious command and control servers or this kind of activities. We'll analyze the startup. So looking at the autoruns, the registry, the services, drivers, as those scheduled tasks. So everything which is started at the endpoint boot. We will analyze logs. So with the use of a tactical SIEM, the EDR will collect the logs from the endpoints. So all the events, the accesses, antivirus logs, logs from the browsers, USB activities, and so on. So from there, we will be able to use our SIEM platform to perform researches on all these events and to try to detect the TTPs and malicious activities. We'll perform a memory analysis. So it's very important during forensic to look at what is loaded into the memory. We will be able to detect some web shells, also some tools like Cobalt Strike or so on. So it will perform this analysis for us. We will use a YARA engine. YARA is more and more used to detect TTPs and specific artifacts, so including into the memory. So all these tools, all this collection will be automated by our tool. So it's a huge gain of time when performing these activities. Otherwise, you will have to use different tools, different scripts to collect all this information. And we really don't have the time when this type of scenario is occurring. So we'll try to identify IOCs from all these analyses, again, to identify the TTPs of the attack. For example, trying to identify if persistence mechanisms have been used by the attackers to stay in the network. And all of this will create cyber threat intelligence, which will be enriched for threat hunting. So we want to block the maliciousness. So for this, we will use configuration of the tool. We will be able to put in place new patterns, new test, new detection alerts. We can perform this on not signed binaries, for example, binaries that are executed in specific paths. We will be able to trigger alerts on encoded commands that are often used with PowerShell, and so on. We will use our integrated artificial intelligence, for example, to detect automatically ransomware behavior, to analyze the binaries with a sandbox. From the identified IOCs, that could be, for example, hashes of binaries, specific registry keys, spatial IPs, IP addresses, and domain names. So with our integrated CTI, and we will perform sandbox analysis with multiple antivirus systems, including VirusTotal tools. Automated remediation, so that's a painkiller here, because with no click, we will be able to kill processes and to quarantine malicious processes. So this will be live blocking of all these activities, which is different from passive incident responsive tool, where you are just looking for specific IOCs, specific artifacts, but you can't act automatically. You can't program the kill of a process or this kind of live response. You can perform a network isolation of the endpoints, which can be automated, which will help us if the attacker is still present and still trying to move into the network. We will provide what we call vaccination. So that will be the list of TTPs identified, coming with the IOCs, coming with the special events that we have identified. And on all the endpoints where the EDR is installed, it will automatically, again, protect the network. And then we'll be able to do threat hunting based on all the collections, all the informations collected automatically by our tool to identify new potential activity and potentially new endpoints infected. So as a conclusion, we have seen that it's easy and quick to deploy an agent on a network. We have a lot of time saved for the forensics because all the informations are collected automatically, which is not the case with other tools where you have to perform special commands and use the tools one by one. It provides intelligent protection and remediation, so that's fast and efficient with the production of a vaccine. And all of this made it a better incident response approach to response to advanced incident and threats. I have included some links for you to review if you are interested by this topic, and I will be happy to answer your questions when it will be possible. So thanks to you. Thanks again. Have a great day.